about the transistors and p-n diode, and as well as whenever the transistor used as a switch and amplifier, and we discussed about the oscillators also. Now we are coming into the another topic, the most important topic in for nowadays we are using severally using in electronics. Those are about the digital signals. What is meant by the digital signals? A signal, either voltage signal or current signal, is having the whenever they are having the two discrete values are called digital signals. Means whenever the signal, either voltage or current signals having the two discrete values, those are called as digital signals. The process means which is the devices or the process which is going to which analyze or generate, which has to transfer the signals by the devices are called the logic gates. Means digital signals of which is using for the electrical circuit. Means here we are given an electrical circuit based on some logic and connected between the inputs and outputs. That means to say here when the circuits which are used to process digital signals, means here a circuit which is used to process the digital signals. Already we have told you what about the digital signals. Whenever the signals are having that only two discrete values are called as digital signals, and a circuit which is used to process the digital signals are called logic gates. Here the logic gates are based on that Boolean algebra, because of he invented that Boolean, he invented the logic gates about that. So that's why the whatever the resultant, whatever the output we can get, that is called the equation or called as a Boolean algebra. According to to analyze the output values by giving the input values, here the logic gates based on the Boolean algebra, so that's which is having the two values only, which are having the two digits. Those are 0 and 1. Here also signal is having that according to the based on this numbers, that is two digits, that is 0 and 1 binary digits. So this is about according to this binary digits 0 and 1, what is and three operators can be operated by the digital signals can be operated by the three operators. Those are OR and NOT, OR and NOT. These three operators can be operated the digital signals by the gates. We can analyze that the outputs by drawing here truth tables, between the input and output whenever it is having there. When the logic gates are having the two or more input poles, and as well as the one pole is the output signal. So that in case of whenever the input is given in OR and or a NOT gate, the meaning of 0, if we give the 0 input to the one of the terminal of the gate, then what about the meaning of 0? 0 means it's a false or off or low or open. These are the meanings, or no. These are the meanings of 0, which is gates operated by the digital signals, which is having the two digits, that is those are the 0 and 1, which is operated by the three operators, those are OR and NOT. Those are the operators. By using this one we can construct the gates. So that here the meaning of 0 and 1 is the 0 is a false, off, open, means here false, off, open, low, no. These are the meaning of 0, and the meaning of 1 means true, on, S, close, high. Means here we are taking that values for here. Let's see here once the values which is given to that, we can state it's a true or false in logic. There is a true or false in a logic, true and false in a logic, and as well as here the on and off are in electrical circuits, on and off in electrical circuits. electrical circuits, and as well as here 0 and 1 in mathematical sense. 0 and 1 in a mathematical sense. Means here we are taking that whenever the input is given in true or false system, then that can be considered as logic. And whenever if we give the on and off, that will be in the electrical circuits, means switched on and switched off like that. And if we give the 0 and 1 in a digits, then that will be the mathematical sense. Whenever we give the logic sense, then true or false, then it can be there. States that true means it's a switched on, false means it's a switched off. We are not connecting anything. The open means in this case of we are discussing about that, this is about logic gates. In that logic gates, the three operators are there. In that first operator is a OR. First operator is a OR. Let's see what is the operators and gates. According to the Boolean Algebra, there is the operators and gates. This is the OR operator. OR operator is basically used for symbolically for the addition. Addition symbolically we use for the addition, used to addition symbolically, it is represented by the plus. For addition, A and B means here we can see that there is a two signals are there, consider it's a A and it's a B. It's a A and it's a B. So here A, B, one we can write that the resultant whenever it is a Y is equal to A plus B. Here this is the Boolean expression, Boolean algebra expression, Boolean algebra expression. So here it is that we can read it as A or B, A plus B can be read as A or B is equal to Y. This is the Boolean algebra. Whenever the addition symbol we get the between the two A and B inputs, then A or B is equal to Y according to the Boolean algebra. Further, in case of the OR operator, this is the circuit, electrical circuit of the OR operator. Let's see how this operator can be gives the output values. Here, that according to the truth tables we are drawing. Let's see. First of all, inputs we are giving that. Inputs means it is already biased. So whenever it is A is open, switch 1, switch 1 S1 and switch 2 is S2. So both are open. Can the conduction is there? No, because of whenever it is comes to current is flowing through the circuit, this is also open and this is also open. There is no connection between the output and input terminals. So that's why it is also open and it is also open. So that's why can the bulb glows? No. So no bulb glows whenever the both switches are is in open. The next output, the next input is open. Switch S1 is open. It is opened and switch S2 is closed. Means whenever the switch S2 is closed, then the conduction will be happen through the S2. Because of S1 is open, there is no conduction through the S1, and in that case the S2 is closed. S2 is closed, so that's why the conduction will be happen through the S2 and bulb glows. Because of the conduction is there. So that's why S2 is a bulb glows. Yes, bulb will glows. The next one, input S1 is closed. S1 is closed and S2 is open. S2 is open. Then whenever this goes, then power current flows through the circuit and passes through the S1 switch because of S2 is open. So that's why S1 the current flows through the S1 and bulb glows. So whenever the current passes through the S1, so that's why we can write that S. The next one, when both S1 and S2 both switches are closed. Both switches are closed. Total circuit is connected. So that's why that is whenever the inputs are given that, then S1 and S2 both will be connected. So current flows through the both circuits. These two switches are parallel. These two switches are parallel. So that's why here the current flows and bulb will glows. The resultant Y is equal to A plus B means output we can get that yes. Means here when the A OR operator, in the OP operator, either any switch is connected or any switch is closed or the all switches are closed, then only the output we can get the bulb will glows. When the two switches are open, only the bulb does not glows. So here it is that when S1 and S2 are both are open, then only there is no connection. There is only whenever the two switches are open, there is no current flows through the circuit. Bulb does not glows. This is about OR operator. By using this circuit diagram, then OR gate, how the OR gate can be constructed and how the OR gate can be connected in a electrical circuit. How do we get the values, output and input values by connecting the, what is the practically, how can we connect the OR gate in the circuit? Let's see. This is about a OR operator. Now we are going to know about the OR gate. So OR gate is having that 2 or more inputs and 1 output signal. So there are two or more signals in OR gate and one is output signal. Here is the symbol of the OR gate. Let's see, this can be like a curved. Whenever we are writing the symbol, just listen carefully, see carefully. This can be curved. This is the A terminal. We are giving the inputs here. This is inputs and this is the output. We can get that. So the OR gate is having that 2 or more input signals and 1 is output signal. So from that, here we can get the truth table like this. Then let's see the realization of OR gate. How do the practical values we can get by using the OR gate? This is, we are having the 2 diodes, that is D1 and D2 diodes, and here is the input. We can get that, we can apply and we get that output from this place. This is the from the load resistance, whatever we hear from this place, we can get the output values. Let's see how the truth table can be satisfied. How do we get the values? For example, here I am connecting the battery. Consider it's a 5 volts we are applying and it is grounded at 0 volts. The ground, whenever they are grounded, that is 0 volts. So first of all, the inputs we are giving that the both are grounded. Both are grounded means A and B are grounded. Whenever both are grounded, then the 2 diodes are reverse biased. Because of this, the plus terminal is minus terminal. Whenever it is grounded, that plus to the minus, and so that's why it will becomes the reverse biased. So whenever it is reverse biased, that A is equal to 0 and B is equal to 0, there is no any conduction between through the diodes. So that's why the output becomes Y is equal to 0. Means input is 0 and output is 0. Whenever the both input terminals are grounded, for example, I just told you that whenever we are applying it is grounded, then here the A is equal to 0, B is equal to 0. Because of there is no any conduction through the A and B. Here there is no any conduction through the diode 1 and diode 2 because of they are reversely biased whenever they are both the inputs are connected to the ground. So there is no any output, so that's why Y is equal to 0. That means to say A is equal to 0, B is equal to 0, then Y is equal to 0 because 2 inputs are grounded. For example, B is grounded. B is grounded means whenever it is grounded, B is equal to 0. The A is connected to the battery which is having the 5 volts, which is applying the 5 volts battery. One battery is applying the 5 volts. So that's why we are connecting to the A. 5 volts battery we are connecting. Whenever the A is connected in the circuit, that considered as A is equal to 1. A is 1 means it's a closed thing, means it is applied. So the circuit is applied. So 5 volts of current we are giving that. Then the A is B is grounded. So that's why here A is equal to 1 and B is equal to 0. B is equal to 0 means it is reversely biased. D2 is reversely biased. Whenever the battery connected to the D1, it is forwardly biased. Current flows through the D1 diode and voltage we get output. That is whenever the 5 volts voltage is connected to the A input and base is 0, then diode 1 is forwardly biased and diode 2 is reversely biased. So from through the diode D1 the current will flow, then we can get the output voltage from here. That's why Y is equal to 1. Output voltage we can get. ay is equal to the resultant according to the Boolean algebra, that is y is equal to 1. The next one, if in case of A is grounded and B is connected to the battery. A is grounded and B is connected to the battery. A is grounded and B is connected to the battery. When here A is grounded means A is equal to 0 and B is grounded, B is connected means when D1 is reverse biased, whenever it is grounded it is reverse biased, there is no any conduction. So that it's a non-conducting diode, there is no any conduction through the D1, and whenever it is connected to the D2 diode, through the D2 diode the current will flow through that we can get the output voltage from this output. Whenever we can get the B, D2 diode allows to pass the current through it, and so that's why we applied the battery 5 volts of battery, then we can get the B is equal to 1, then Y is equal to 1. Then after that both terminals are connected to the battery. Both terminals are connected to the battery. Then D1 and D2 both will be forwardly biased and these two are parallel to each other. Means that is A is equal to 1 conduction will be happen through this one, or D1 also conduction will be there, and through the second terminal, that is B input also there is a conduction. Both will be parallel to each other, so that's why output we can get like this. When A terminal A and B terminal both are grounded means 0, then we can get the output is 0. Then only in this case of if the inputs, the output signal is high, let's see, the output signal is high if any or all the inputs are high. Let's see, the output signal is high, here is it. The output signal is high if any, here is the one of the I is there, here is the one of the I is there, or both are the high is there. If any or all the inputs are high. If in case of any one input is high in the OR gate, then we can get the output. If the all inputs are high, then also we can get the output will be high. This is about OR gate.